Colorado Plateau within large stretches of Arizona, Utah, Colorado, and New Mexico is an alien-like landscape that marks the setting of almost every Western film in existence. Here, towering monoliths of sandstone and other sedimentary rock tower over the surrounding grasslands, deep canyons carve through the landscape, and numerous plateaus jet out over the wilderness. The reason all of this unusual landscape came to be involves the geologic province it is a part of, the Colorado Plateau. This vast province across 4 states covers an area of 130,000 square miles, which is about the same size of Finland. The reason why it is called the Colorado Plateau is that as almost a singular supermassive block of crust, this entire area has been uplifted by nearly 8,500 feet or 2.6 kilometers from its original elevation. This uplift forever changed the geologic landscape of the southwestern United States, and even led to recent volcanism. However, despite the fact that 1 million people live on this scenic province, we didn't actually know why the Colorado Plateau was uplifted until very recently. While some specifics of this uplift that pushed older sedimentary rock units to rise above younger low-elevation rock units outside of the plateau are still debated, we are fairly sure that uplift began around 80 million years ago. However, instead of a continuous rate of uplift occurring, timing of uplift throughout the entirety of this timespan, it instead took place via differing rates during 3 distinct periods with absolutely no uplift between them. These periods of uplift lasted from 80 to 50 million years ago, 35 to 15 million years ago, and 5 million years ago to the present. 80 million years ago happens to represent the same age that the Rocky Mountains began to form, and this is not a coincidence. As, at the time, what was known as the Farallon tectonic plate was plate subducting underneath the North American plate off the western coast of North America. However, this subduction was occurring at an unusually low angle in what is known as flat subduction. When partial melting occurred on the shallow subducting Farallon plate, dense molten rock in addition to water was emplaced into the bottom of a section of the North American plate. As sections of the denser asthenosphere invaded the lithosphere, it made the lithosphere become increasingly dense in sections, eventually surpassing a point which caused the section of lithosphere to start to peel away. Soon, much like a drop of sap falling from a tree, material pooled in a drop of lithospheric material before completely detaching from the surrounding lithosphere in what is known as a lithospheric drip. Then, large amounts of hotter material in the mantle rushed upwards to fill the empty space in what previously a section of lithosphere, and this motion pushed the crust upwards. At the same time, magma intruded into weak points on the uplifted plateau, forming scattered volcanic fields on the surface. The lithospheric drip after its first iteration now no longer needed the Farallon plate to occur, forming a positive feedback loop which caused more cycles of this to take place. These cycles, after temporarily ceasing 50 million years ago, resumed 35 to 15 million years ago, only to be followed by the same process which has occurred since 5 million years ago. Once material was uplifted, which was 1.4 to 2.6 kilometers in total depending on the source, higher levels of rain fell, allowing for increased levels of erosion to carve away the uplifted rock. This very lithospheric drip process was recently confirmed to be actively ongoing lithospheric drip today underneath the Colorado Plateau in a broad region between the north rim of the Grand Canyon and Cedar City in Utah. And this is why several young volcanoes exist in the western section of the Colorado Plateau. As a final note, I would like to thank my new patron Freedom Zero Gundam for supporting this channel.